Hello, this is John Baugh again, and welcome to another exciting episode of CIS 2353. This week we will go over array-based lists. So that's chapter 6 in the Collins book. Alrighty, so let's get started on that. This chapter, as always, it has some examples in it that I won't be doing live here. If you need further assistance, you can feel free to ask me, and I will try to create materials that will explain something further if there's something that's not clear. But they give a ton of different examples. Some of them I might use a modification of them, and some of them I might just leave for you to do as an exercise for your own benefit. But array-based lists. So this starts our topic of lists in general. So lists ultimately all implement the list interface. So a list really, when we say that there's a list interface, there is literally one in Java, but we can also think of an interface as far as the user's perspective, which really is why Java has interfaces to begin with, is that there are certain methods and certain behaviors, certain ability to interact with the data structure behind the scenes that one would expect with a list, regardless of how it's implemented behind the scenes. And in this chapter and the next, we cover two very different implementations, but they ultimately offer the same functionality, the array list and the linked list. So array lists use an array as the data structure behind the scenes, whereas a linked list uses a linked structure behind the scenes. We'll talk more about linked structures in the further. You'll notice that everything ultimately is implementing the collection. Collection list actually, quote unquote, implements collection. So it extends collection. And then here you have abstract list implementing list. And then these two, the array list and the linked list, do implement abstract list. So ultimately they're implementing list. As a reminder, this is the kind of stuff that we have in the collection interface. You've got size is empty, contains, iterator, toArray, add, remove, contains all, add all, remove all, retain all, clear, equals, and a hash code. So there's quite a bit of stuff available to us in collection. However, there's more stuff available to us with the list interface. And you notice most of these are allowing us to treat this list like an array. You have get, you have set, index of, add, and remove. So to go over those again, the get will actually return the element at a particular position within the list. When we say list object, we made an object that ultimately is implementing the list interface. So set allows us to replace a particular element at a position. And then index of, given a particular object in the list, if that object appears in the list, it returns the index of the object. Otherwise, it will return a -1 if that object is not found. Add, given an index, allows us to add a particular element, and it moves all the other items over if need be, depending on the implementation. You'll note that an array implementation versus a linked structure implementation behave very differently with that. However, they both perform add. Remove allows us to remove and then return the element at a particular position in the list. So with the array list, we have what they're calling they're saying this is like a classy array. So it's a little bit more powerful than what we're dealing with a standard array. It allows us to get to have random access of an element given the index, and so we can get and set. And we can also insert or remove an element at a given index as well. So you can add to a particular element. You can add a particular element at an index or remove at a particular index as well. There's also one major benefit to array-based lists as opposed to standard built-in arrays is the automatic resizing. So if you call add, it allows, or the array will automatically resize if it needs to. So if it's not big enough to hold a new item, it will resize and then make room for the item. Whatever that means behind the scenes for us. With an array list, it means changing the size of an array, or rather creating an array of another size, copying elements over, etc. But the array list takes care of that for us. So here are some of the things available to the user. They've numbered them. But you've got the constructors, 3 constructors available, several add and add-alls, a clear. Clone method allows us to make a copy of the array list. Contains tells us if the array list contains a particular object. Contains all. Does it contain all of the elements that we pass in? Ensuring capacity equals get hashcode index of. So some of these are coming from the collection. Some of these are coming from list. Okay, so you've got size, that comes from our friend the collection, set, and remove, those are coming from our list. So if we were to write a process input method that converts the string that's passed in to an integer first, the line that they use for that is actually, they use a kind of a little sneaky line here. They use the scanner and then they use the next int. It will construct an array list that holds up to n double values. In a loop with I going from 0 to n minus 1. You append I to the array list. Public boolean add, so use add. Then after the loop, they will insert 1.4 at n divided by 3 index. They will remove the element at 2n divided by 3. And then multiply the middle element by 3.5. And then finally they'll print out the array list and using the toString method. So they start building on it. They kind of do it one by one, but I'll go to the finished product here and we can look at it. So right here they use kind of a clever way to cause this string to be converted to an integer. So they take the scanner, pass the string to the scanner, scans the string, you call next int, and it will interpret the entire string passed in as an integer. As we know, there's multiple ways to do that. Parse int, etc. We could use a bunch of different ways to do that. But then they create an array list of doubles. Notice again, since it's an array list, you have to use the wrapper class double, not the primitive type, because array list has to contain objects. It can't contain primitive types. Then we have a loop right here where it adds the, we cast the double, cast the I to a double. I think that's one too many parentheses they've got there. Yeah, so it doesn't need that extra parenthesis. There's too many parentheses on the left side. But they're looping through and they're adding all these items to the list. And then as we specified in the original, you've got all these additional items that they're adding and removing, and then they're printing out the list. So if S contains 10, the output is this. So it'll go from 0 all the way up to 9. So it's an exclusive thing. Alright, so they go through, do a couple examples. The ArrayList class heading looks like this. It extends abstract list, implements list, random access clonable, and also serializable. So serializable allows it to be serialized, which we'll look at in a different chapter. And clonable allows us to copy it or clone it. So they can be saved to disk. That's what serializable means. As a series of bytes and later read from disk, which is called deserialized. So that's basically allowing you to save and read in objects if they're serializable, so they can restore it to their object state. It's very helpful. So copying a collection versus copying a reference to a collection. Now I try to stress this in all the Java courses that I teach, 1500, 2151, 2353, and also at a course I teach at the University of Michigan, which uses Java. I stress this over and over and over again. There's a difference between the object and the reference to an object. And in Java, anything that is not a primitive. We've got the primitives in Java, which are what? We've got byte, short, int, long. Those are the integer types. Then you've got float and double, real number types. So that's 6. Then you've got Boolean and char. Those are the only primitive types. Everything else in Java is a reference type. So that means they hold an address. So basically when you say array list of strings, mylist1, this variable right here, mylist1, can only hold one thing. It does not hold an array list. It holds an address of an array list. This memory is allocated dynamically, which means that the memory, new array list, when you see the new keyword, that means the memory is allocated dynamically, which means it's on the heap, and that it is allocated at runtime, not compile time. So we've got the memory right here that's allocated at compile time. mylist, mylist2, mylist3, any integers, any primitives, shorts, longs, ints, doesn't matter. Those are all allocated at compile time. And even, as I said, the memory for these right here, these actual variables, is allocated at compile time. However, the actual object, the ArrayList object, and any of the actual objects are actually allocated at runtime. So it's dynamic memory allocation as opposed to what we call static memory allocation. So once you've created this array list, let's say we add Kona to the list, and then we say mylist2 equals mylist1. Well, the effect is not to create a brand new list and then add Kona to it. It actually just has two references to the same array list. Because think about what a reference holds. mylist2, mylist1, they're both references. So that means that they hold addresses. They hold nothing but an address. So that means all you're doing here is copying the address of mylist1 into mylist2. So that means they're both pointing to the exact same object on the heap. So if you modify one of them, it will modify, or you modify the object through one of them, it'll modify both. However, mylist3 uses a constructor called a copy constructor of array list of strings. If you pass it mylist1, it doesn't just cause it to point to it, it actually makes a brand new copy. So mylist3 is actually a copy. So it does contain Kona, but it's a complete different copy. So here's what actually is happening here. You have mylist1 and mylist2. They both contain the same address, so effectively they are pointing to Kona here. Okay, one object. mylist3 used a copy constructor, so what happens inside is that it creates a brand new object and then just copies the data over from the list that was passed in. So it's a different thing that's happening. Different memory locations. So let's look at what happens here. If I say mylist2 adds Kamwela and then mylist3 adds Kaihai, you have this. mylist1 and 2, since they are pointing to the same object, even though we affected it through only one of the objects, mylist2, it does affect what mylist1 is pointing to too, since it's the exact same object, Kona and Kamwela. However, mylist3 is a completely separate copy of this. So Kona and Kaihai are what are available to you. So fields in the ArrayList class, you have the element data, the size, and you can set the initial capacity. They're showing you some of the code here of what actually is going on with ArrayList, but it does not mean that that's the that you have to know exactly how it works. They're just showing you how it works. Should be aware of how it's working, but they take care of it for you. So this, if you have a default constructor, it actually creates an array list of size 10. That's the default size, so just keep that in mind. But it will, as you add items, let's say when you add the 11th item, it will automatically resize. Okay, so they go through and they take you through the ensure capacity. Notice that ensure capacity, make sure you have enough room. And then you set the element data, which is the backing array that lives inside the array list, that you do not directly access as the user of the array. They set it to whatever the size is currently to element, and then size is incremented here. That's a little bit of a confusing statement, but what it says is element data at the current size is, we made the capacity larger here, but then element data at the current size, that X is now the new largest index, equals element, and then size is incremented after it's used as an index, because we have postfix increment notation right here. And then it just returns true. You've got the ensure capacity code they show you. We're not going to go through that, but it's basically making sure that there's enough capacity to hold the elements. So we don't have to worry about that. Oh, iterators are not needed for array lists. So you can just say int j equals 0, j less than my list size, j++. So let me go into Eclipse real quick here, and I will create an example. We'll call it array list test. Public static void main string args. Okay, array list of strings. My list equals new array list type string. Okay, notice it does not know where array list is coming from. It's actually supposed to be from java.util, so we import that. java.util.ArrayList. And then below that, let's say I add mylist.add John, and then mylist.add Bob, mylist.add Samantha, mylist.add Carlos. Okay. So you can loop through and print out all these elements, or you can just use the built-in print statement, or which actually is the toString. So you can use the print statement and then call it directly on the array, which will actually print out the contents of the toString. So you'll see it'll put brackets on either side and then put John, Bob, Samantha, Carlos, the order in which they were added. You can also use a loop. Okay, so we're going to try to do a loop here. Int I equals 0, I less than, and the property that you want to access to go through the list, or to get the length of the list, is mylist.size. Okay, so it's a size method. So it's a little bit different than what you're dealing with regular old arrays. You use the size method instead of the length property, and then you can print out each element however you want. So for example, if I want them on individual lines, I'm going to get the item at I. So I'm going to print it out. So John, Bob, Samantha, Carlos, and we also see I'm also calling the toString version up here. Because remember, if you just pass an object or something to a print line method, so any object reference type, it will automatically call the toString. You don't have to put toString at the end. It will automatically try toString if what you're passing it isn't a string already. Notice there's also alternative syntax for this, for the for loop. That's a regular for loop. You can also use an enhanced for loop. So you've got for, and then since we're dealing with an array of strings, I'll say string s, then colon, my list. So basically I'm saying for every string inside of my list, I just want to print out that string. So this effectively has the exact same effect as earlier, since we don't have to access or don't need the indices from in here. So you don't need the index. You can just print it out. So this is a good read-only way you can print out your list. So it does exactly the same thing as the for loop above, but just know there's more than one way to do it. Okay, so the iterators are not needed, but they are legal. You can create an iterator. For example, if you have an array list of doubles, you can create an iterator double equals mylist.iterator. It retrieves the iterator, and then you can go through there and use the iterator, but you don't really need to. This, they're showing you the enhanced for loop. They also give you an example. We're not going to go through the details, but they give you an example of how do we do high precision arithmetic. In many different fields, there are very, very huge numbers that are needed for those particular fields in mathematics. One that's an applied mathematics that we use in computer science a lot, in cybersecurity and homeland security and all kinds of different areas, information assurance, is cryptography. Cryptography uses very, 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 very large numbers sometimes. So they're actually extremely large integers. Cryptography largely depends on properties of various integers, so prime numbers specifically. So the problem is that the limits on even longs in Java is that they're just not big enough to accommodate. So if you were to do an actual industrial strength application using cryptography, you would use a data type called big integer. So I would highly recommend you look into that. The big integer class that's available. But they do give an example in this chapter that they have you make a custom large integer class. And the idea behind it is that you basically put a digit at each index within the array list so that you can make arbitrarily large integers. So it's a pretty interesting example. So in public key, or what's called asymmetric cryptography, the integers can be hundreds of digits long. That's way bigger than what Java can accommodate with the primitive data types. So you can either make your own or you can use big integer. But that's the preferred way to do it. They're just showing you how to do it with something they're calling very long int. Okay, so they're creating one for you. They have some exercises that you can work on as well. To generate a very long integer, it's actually not that consuming. It's a polynomial time, so it's big O of n cubed to generate a very long integer of n digits that is prime. The average time is big O of n cubed. So if n is 200, n cubed is 200 cubed. So it takes 8 million iterations to generate the n digit long or 200 digit long number. To factor it, it's extremely difficult. This is why one of the reasons cryptography is so strong is that to factor a very long integer of n digits that's not prime, the average time is big omega of 10 to the n over 2 for any known method. So it's 10 with 100 zeros after it for even just for 10 or for n equals 200 digits. So to factor the primes, it would take exponential time. So that could take a really long time. Given P and Q, P multiplied by Q is used to encode the public message. To decode it, you have to know P and Q. So they basically serve as the key that you need, the secret key. So they go through here and they show you how to create this. They give you the specifications and show you how to use this particular class, how to build it and use it. So I won't bore you with the details of that. I would say take a look at it, see if you can maybe get it to work. And also look up big integer as well. So how long does the add method take? On average, recall that n refers to the number of digits. So the average time ultimately turns out to be linear in n, because the least method takes constant time, and appending to an array list takes constant time on average. So the average time for add depends only on the number of iterations of the for loop, and that's n. So it's really fairly efficient given how large the numbers we're dealing with in some of these applications. So they want you to go through and define the size method. That should be fairly straightforward. It just returns the number of digits. So that should be a pretty straightforward exercise if you've been messing around with the very large int or very long int class. So it's a pretty straightforward chapter. It's actually fairly short, and that's pretty much on purpose because they want you to really spend some time looking at the array list. I want you to, personally, I want you to make sure that you understand the different methods associated with it and how to use an enhanced for loop as we did here, and also how to use a regular for loop that you use. For regular arrays, you would use length property, but for these, you have to use the size method. So please keep that in mind. Be able to use get and set with them because that may be important for future programs and such. All right, so if you have any questions, please feel free to email me at jpbaugh@oaklandcc.edu.